BIT SINDRI, DKC, HOD, Mechanical Department, AKC, all other department HODs, deans, member of organizing committee, technical committee, coordinator, co-coordinator of one week faculty development program on mechanical engineering MED 2021. First, I would like to call Dr. S.K. Singh, Professor and Head Department of Mechanical Engineering Department for welcome speech. Sir.
Thank you. Very good morning to everyone. It is a glorious moment to extend my warm wishes to all the participants on behalf of the Mechanical Engineering Department of BIT SINDRI. I want to convey my heartfelt gratitude to our Director Sir for accepting our plea for organizing this.
Director Sir का दे दूँ slide. ये live ना, ये हम live है. एक second.
Okay. Sanjay sir, thank you.
हम live.
Sanjay sir, you are not audible. Now, I would like to call Director BIT SINDRI, Dr. DKC for speech about this May 2022.
Thank you, Professor Dhaneshwar Mathur Sahab and HOD Professor S.K. Singh Sahab. At the outset, I would like to thank the Department of Mechanical Engineering to conduct this type of the FDP, the emerging area in the mechanical engineering. It is really a good initiative by the department. So I congratulate the Department of Mechanical Engineering, the course coordinator and the convener who have taken this initiative to just make them aware, the students and the faculty member. So once again, good morning to all the faculty members, organizers and the participants who are attending this workshop. When I got the invitation from the course coordinator, Professor Chandan Kumar and Professor Dhaneshwar Mathur, that we are in the HOD, Professor Singh, that we are going to conduct a FDP program. So I started surfing the course brochure. This brochure was the focus on some of the emerging technology. So I found that this is not only exclusively for the mechanical engineering, rather it is common to many of the engineering programs. You have taken the first, the drone technology. The drone technology, I have also interest in that drone technology because most of the communication engineering is also involved in the drone technology. So drone technology, we are using the 7th generation of the drone technology where the equipment, this is also called unmanned air vehicle, UAV or unmanned aeronautical system, where a lot of sensors, the equipment is having a lot of the sensors, transmitters and the communication device. So at the ground level, we have a controlling station. So electrical control is there, the signal is required to be intercepted. So the new technology through which now the drone has come out of the military zone, mostly from the First World War, the US started using this drone. But it was confined up to 90, up to the only the military were using this application. Now Amazon is using to transport their commodity from one point to another point. So now the research area is to have a good quality sensor should be there, a precise equipment, precise location should be there. You have observed in the Israel-Palestine wars, right, the GPS control radar system were being the GPS control missile system were being used. So how the technology is developing? Now there is the integration of the technology. So you people have chosen a very good area. So in the drone, A lot of work, a lot of research is required either at the ground level or at the communication level or at the equipment level. So it should be integrated, it should be precise. So now people are working on a smart drone technology, and this drone has come out of so many things has to be controlled just to gather the information for the intelligence and the surveillance purpose. Now your second one I was going through was the rapid prototyping. So rapid prototyping is also a very emerging areas that people are using. Now we are thinking about electrical car. So we all are facing energy problems. So how those energy problem can be solved? We should have electrical car at a very fast rate. So this rapid prototyping in the 3D technology is going to bring the electrical car within 5 to 10 years, and this fuel-driven, petrol and diesel-driven car and the vehicle will be replaced easily. So you have taken a good area in the rapid prototyping. A lot of research work is there. So I would like to share to the faculty member and the students who are pursuing their research program, because every constraint is a research problem. And what the researcher is supposed to do it, you go through the literature survey. So you just take one of the domain and start working in those areas. So the rapid prototyping in the 3D printing. So through the three-dimensional computer-aided design, you can fabricate the scale of the parts, you can assemble the different parts very easily. So prototyping is one of the areas where the researchers should take the assignment and can carry forward the research for a greater benefit of the society. Now the third one I was going through was the composite materials. So the composite material is one of the emerging areas. So composite material is nothing. Two or more than two constituents are being mixed together to have the electrical, mechanical and the other property as per the user requirement. And the best material now the people have developed is a graphene. You see the tensile strength of the graphene. It is 200 times higher than the steel. You see the electrical conductivity and mechanical and the thermal conductivity of the graphene. So graphene is a material, it is the best material, composite material. People are working. So it has given birth to the nanotechnology and other technology. So one should take, so I hope I'm welcoming all the speakers, Professor Vikas Rastogi from the Delhi Technical University, Professor S.L. Burma from the East Noida, people from the industry, Bhom Ranjan Singh, Vivek Kumar, right, Professor Anupam Kumar, Professor Vinit Sekher, and the other experts who are going to throw light in the different area of the FDP. And I think it is going to make open so many research issues and make aware to the students and all the faculty members all around the country who are participating. So you have also taken optimization techniques. So optimization techniques, we all have gone through. Before the IT era, mostly we were focused on a deterministic system. In the deterministic system, we were having a linear programming, the differential equation. But the real world is not a deterministic system. The real world is mostly the impractical system. It is not indeterministic system. So we require a heuristic search techniques. But this technique was available right from the 1900s. But it was not possible without the use of the computer tools or the software. And because of these IT tools are available, now we are having a genetic algorithm, we have the ant optimization techniques, we have the neural networks, we have the fuzzy networks, and this ant and other we are using in the different area of the engineering problems. So this optimization technique is one of the area where easily one can publish a paper, which can carry a paper to find, carry a work to find a exact solution of a problem. So this is possible because of a powerful tool, IT tools we have now available. So I congratulate the Department of the Mechanical Engineering, Professor Singh and his team who have taken these areas, and I hope with this 5 day, is it Professor Singh 5 day or 6 day?
6 days, sir. One week.
It is FDP, 5 days.
6 days, sir. 1 week we have taken complete. 6 days.
6 day. So I hope this 6 day FDP program with a galaxy of the experts from the academic institution and from the industry and our internal experts, the so I think the coordinator should request everyone, whoever is not speaking should have mute the audio and the system. So control it. So I hope it is going to make open, expose our participants, the different areas and the different technology which is knocking our door, because a country is only powerful when the country is technologically empowered. You see the growth of the China. China got independence after us, but you see because of the technological advancement. 2 days or 3 days back, I got through the newspaper, they have the land rovers on a planets, different planets. This is the China as first, right, Sumar. So our country can be recognized a powerful and the best country when our faculty member and the researcher and the coming generation are doing the research in the cutting technology. So I hope with this initiative, the Department of Mechanical Engineering will successively come with many more faculty development programs. We all are going through the pandemics, so this pandemic has also opened has made a revolution in the education sector. Now the education sector has become completely digital. Now conducting a FDP program, workshop and seminar is very easy. It was very difficult earlier in a physical mode. So with these words, I wish all the HOD Mechanical Engineering and his team member or faculty members for grand success of this FDP program. And once again, I welcome the faculty members who are experts in this FDP from the different colleges, like Professor Rastogi, Professor Burma, Mr. Byubhom Ranjan Singh, Dr. Vivek, and Anshuman Anupam Kumar, and all the participants to have a grand success of this FDP. So thank you very much. So over to HOD Mechanical, Professor Course Coordinator, Professor Mathusha.
Okay, thank you sir for giving the valuable words about the faculty development program for mid-2021. Now I would like to call Coordinator Dr. Chandan Kumar for briefing the FDP program. Chandan sir.
Sir. Good morning everyone. मेरी आवाज आ रही है सर?
Yes sir.
Audible?
Yeah.
Yes, audible. Go ahead.
धनेश सर, मेरी आवाज आ रही है धनेश सर?
Yes sir, you are audible.
Thank you.
Please go.
Okay, thank you.
Please continue sir.
Good morning one and all. Respected Director sir, Dr. D.K. Singh sir,
Please unmute,
Director
sir.
BIT SINDRI, members of advisory
Please
committee,
unmute your voice, sir.
all the deans,
Unmute yourself.
heads of the department,
Professor Chandan Singh,
professors and
unmute
dear
yourself.
participants and dear colleagues.
You are
Once
muted,
again, on
Professor
behalf of
Chandan, you are
organizing
muted.
committee,
Please unmute.
I would like to welcome all of you in the 1 week FDP
Chandan
on
sir,
Mechanical
please
Engineering
unmute.
Emerging Technology Meet 2021. This event is
Chandan
due
sir,
to the
you are
motivation
not
of
audible.
our respected director sir,
Madhu
Professor DK
Sahab, please
Singh.
call him.
It is really outcome of his
Yes, sir.
initiative
Please
only.
call him personal level
शिट पापा अरे हम म्यूट
and
पर
guide
हैं
him.
किसी को आपकी बात नहीं सुनाई दे रही थी
Now he is unmuted. Professor Chandan, go ahead.
Chandan sir, please repeat.
Some technical issue, so I am going to repeat that.
Okay, sir.
This event is due to the motivation of our respected director sir, Professor DK Singh sir. It is really outcome of his motivation only. I would like to appreciate the effort of our organizing team, due to which we got highest publicity, and total number of participants are approx 190. The participants are from 55 different institutes and across the India. As the director sir has elaborated very briefly about the content of this FDP, I am not going to repeat, but this FDP will have 7 different technical sessions, which will cover the latest tools and techniques which may be used by mechanical and other department researchers, faculty members and students. Dear participants, this faculty development program is organized in collaboration of TCube 3. So it is going to be very useful for us, as it may ignite a spark for doing quality research as well as to improve our technical teaching learning process. I humbly request all the participants to attend the FDP regularly. I am confident that this FDP will be very useful for you and you will improve your research. I would like to mention 2 names, Mr. Pulkit Srivastav and Shaurya Singh, who have helped me in making this FDP very successful by giving me technical support from the beginning, whether it is preparation of brochure or it is making it live on YouTube. In case you feel any difficulty joining Meet, you can join our YouTube channel, which is the link has been sent to you in your mail. Once again, I thanks to all the faculty members of the department, member of organizing team, directors or heads and participants for joining this inaugural session and FDP and making it successful. On behalf of organizing team, thanks everyone who are attending the FDP. Thank you very much.
Thank you, Chandan sir, for giving or briefing about the May 2021. Now, due to the
Ganesh sir, you may take now.
Now network issue, there was a network issue. So our HOD sir, Dr. S.K. Singh, once again I like to request him to give a welcome speech.
Thank you, sir. Am I audible now?
Yes.
Oh, thank you. Due to some technical issues, I was not able to join there. Very good morning to everyone. It is a glorious moment to extend my warm wishes to all the participants on behalf of the Mechanical Engineering Department of Mechanical BIT SINDRI. I want to convey my heartfelt gratitude to our director sir for accepting our plea for organizing this wonderful FDP on Mechanical Engineering Emerging Technologies Meet 2021. It is an opportune moment for all of us to get enlightened with our esteemed experts from the different parts of the country, courtesy online platform. This workshop schedule brushes upon a spectrum of exciting and benefiting themes that discuss the aspects of recent emerging trends in mechanical engineering. The world is facing an exciting new technological revolution, bringing with it a recent surge of new trends in mechanical engineering. Looking towards the new era of technology, mechanical engineers are discovering several new technologies, bringing advancements to the world like never before. Many times, we often think that does mechanical engineering have scope in the future? Absolutely. Though the world may be experiencing the fourth industrial revolution, there are still so many ways in which mechanical engineering is growing and developing, opening up so many more opportunities for those who work in the sector. In this workshop, with our esteemed speakers, we will get that knowledge that how mechanical engineering are changing its trends for the benefit of the society. At last, I want to thank all the advisors, coordinators, co-coordinators, and esteemed faculty organizers to organize this FDP. Thank you very much.
Okay, thank you, sir. Thank you, sir. Now, I would like to call Dr. Jitendranath Mato for vote of thanks for an inaugural session. Jitendranath Mato, please, sir.
Oh, thank you, sir. A very good morning to all. It's my proud privilege to have been asked to propose a vote of thanks on this inaugural function. First of all, I would like to extend a very hearty vote of thanks to our Honorable Director, Professor Dr. D.K. Singh sir, for gracing today's function. Thank you, sir, for your very interesting and thought-provoking address. A sincere thanks to all deans of the institute, all heads of the different departments, senior faculty members, and faculty members. Now I would like to thank Professor Dr. S.K. Singh sir, head of the department, Mechanical Engineering at SINDRI, for his welcome speech. I would like to thank Dr. Chandan Kumar, coordinator of the Faculty Development Program, for briefing the program. I would like to thank the organizing committee, the Ervine Executive Committee of the program. I am happy to offer sincere thanks to the participants. Finally, I would like to extend a special thanks to Engineer Raj Kumar sir, speaker of today's session. Once again, I thank one and all. Thank you, sir. Over to Dhanasar sir.
Okay, sir. Chandan sir, can we start the session?
Yes, sir. Yes, now we should proceed for the technical session. Director sir and other invited guests may leave the session or may continue. We are going proceeding for technical session.
Okay. Now today's speaker is Engineer Raj Kumar, who is manager Autotech Information System Private Limited, Noida. Sir, Raj Kumar sir, please come on video.
Wait, sir, I am just sharing my screen with you.
Okay, so before to present the speech, I like to give you some little bit about his credentials is a lot of things, but Engineer Raj Kumar has 11 plus years of experience in industry as well as academic. Currently, he is working as an application manager in additive manufacturing division in Autotech Information System Private Limited, Noida. He also involved in design and development of various additives for industries as well as medical applications. He is also associate in reverse engineering, vacuum casting, tool making, etc. He has served as an assistant professor in Department of Mechanical Engineering at Noida Institute of Engineering and Technology, Greater Noida, and Maritime Institute, Greater Noida. He has also experience in pipeline engineers, quality control, and published several papers in good journals like Scopus and SCI journal. So, Rajkumar sir, I am very warm welcome you for your speech. So, please.
Thank you so much, sir. Good morning to all of you, all the participants, all the guests, all the people who has involved in this FDP. Uh, I'm presenting my thanks from my bottom of my heart. So I have shared my screen. Is it visible to you all, sir?
Yes, sir, it's visible.
Okay, so I am presenting it in the full mode.
Yeah.
Let me introduce about my company. So my company is Adrotech Information Systems Private Limited, and I'm working there in a division which is a 4D Simulations India Private Limited. So which is a further division of the Adrotech group. So Adrotech is a huge group. It is a very old company. It is more than 32 years old company, which is a pioneer in CAD/CAM, additive manufacturing, reverse engineering, and different cutting-edge technologies. So this is the brief description about my company. So I am working there as an application manager in additive manufacturing. So I looks after the various products, I looks after the various applications which are related to industries as well as in order to fulfill their problems. If there are some problems with the industry and that can be addressed with the help of our technologies like additive manufacturing and reverse engineering, then we address them with our provided solutions. So we are having various solutions in that. So here are my credentials, like my email ID is here. You can visit our websites. So there are two websites with us, which are the different websites. One website is dedicated to one of our products, which is the SLA 3D printing technology, which is also known as LFS 3D printing technology, which means that low force stereolithography technology, which is a patented technology with us. So we are having dedicated website for that. Apart from that, we are having various products in additive manufacturing as well as reverse engineering, along with the CAD/CAM softwares, CAD/CAM PLM softwares, which are there with our website. So these are the different products which we are having. So my presentation is navigating or not, sir? I'm now on to the second slide. Please confirm, sir.
Yes, yes.
Okay. So my presentation is basically in this particular thing is related to rapid prototyping, additive manufacturing, and 3D printing. So these three terms, if you look at these three terms, then these three terms are very similar in many ways. But
hello, sir. Sorry to interrupt you, Mr. Rajkumar.
Yes, sir.
Your slides is not means navigating.
Yeah.
Okay, so
No, it is.
I will not make it into the full mode. I will.
So can you put it in the full mode?
Actually, if I am putting it in the full mode, it may not be navigated.
Thank you so much. Please carry on.
So there are three terms. If you look at this, so there are three terms which are rapid prototyping, additive manufacturing, and 3D printing. These are quite similar but different. These are having some differences in many ways. If we are talking about rapid prototyping, this is a term which is associated with the prototyping technology. So in earlier days, if you remember, most of the people were involved in such operations in order to making the prototyping of a component. So in earlier days, before 1980s, if you have gone through those processes, in those days it was very difficult to produce a prototype. So it was a long process. It was the process of making prototyping was taking a lot of time, like years in creating the prototyping only. So there was very tough time to produce a new component and launching it into the market. So in those days, there was the process which was very much manual process which were involved in the prototyping operations. So prototyping operations were very critical in those days. Later in early 80s, in 1983, there was a revolution came across in the prototyping operations. It was the stereolithography technology that was developed with a scientist named Chuck Hull, which is also known as Charles Hull, who was the first inventor of stereolithography technology. So nowadays we know that particular person with the owner of multiple national company which is known as 3D Systems. So now if you know the modern company which is named as 3D Systems is live and founded by that particular person whose name is Charles Hull. So Charles Hull invented the technology and also got that patented and developed a company with the name of 3D Systems in those days. So with the help of this particular technology, it was very easy and it was very fast way to create the prototyping in in different industries. So this was a particular solution in those days in order to get the prototyping done within a short interval. So that is why it was termed as rapid prototyping till 1990s. So when that 1990s era came into the existence, there were several more technologies came into the existence on those days, which was FFF technology, which is also known as FDM technology, fused deposition molding, or you can say fused filament fabrication technologies, came into the existence in those days, and it was there in early 90s. And in those days also, these technologies were not limited up to only developing the prototyping. So there was the actual components which were created with the help of these technologies. So in those era, what was happening? The technology was turning into the manufacturing operations. So that is why that particular thing named as additive manufacturing with the help of the uh, uh, with the help of industries who were using this technology as the manufacturing operation. So this was the time when it was turned from prototyping sections to the actual manufacturing process. Then the era came, actually when the technology came into the uh, contact of those people who are not so technical, those who are common people, those who are not very much tech savvy. So when it came into their touch, then it was named as 3D printing, because those two terms, rapid prototyping or additive manufacturing, were not that friendly with them. That is why it was termed as, in a common meaning, was termed as 3D printing. There are many more names with these particular things, but these three names are very basic, which are available in standard literature. So these are the three terms, and these are the differences. So that 3D printing came into the existence, that particular name came into the existence in 2000. So it was just for those who were not very tech savvy. So I have navigated to the next slide. So is it visible, sir? Please confirm once.
No, no, no.
No, sir.
Okay, so
Yeah,
Yes.
now it's coming. Yes.
it is the best way to show. So I won't make it to
No,
the.
please carry on.
Okay. So the 3D printing is a process of making physical objects from three-dimensional digital models. So this is the very first thing, the basic thing. Actually, 3D printing is just a dumb thing without a design. So still in this particular 21st century and 2021, it is still there. The design is very important thing in order to get any kind of manufacturing operation. So design is the base of any kind of manufacturing operations or the process. So if you are going to create a physical object from any kind of thing, then you need a design. If you are whether you are using CNC machining operation, if you are using any kind of injection molding process, if you are using soft molding process, any kind of process which will be requiring a design, whether it would be the constructive design or the destructive design, that will be a separate part, but you will need a software which can easily create the design. So this is a process of making a physical object, like actual physical object, from a three-dimensional digital model. So digital model is nothing but just your design. So in this particular technology, what's there? Actually, we have to export the file in a specific format, which is known as STL file format. And there are various similar formats as well. So STL is standard triangulation format or standard tessellation format, which we know for. Apart from that, there are various formats like .obj, .ply, .xyz, and there are several more formats which are dedicated to some specific company. So these different formats can be transformed onto the particular software which is known as slicer. So I will come on to the slicer later on. So the process of making a physical object from a three-dimensional digital model is incomplete definition, because it can be done through any of the manufacturing process, any of the production process. So if we are talking about the second point, then the second point is typically laying down many successive thin layers of material. So it means that we are creating a physical model from a digital model, but the process of doing that is dependent on your layering method. You are depositing successive layers. Like if you are having a component, like you are having a potato, you are creating chips out of it. If those chips can be joined together to form a shape of potato, the same process is applicable here within the 3D printing operation. So if you are having a bunch of bread, so bread can be converted into the slices, but all those slices joined together to make a whole bunch. So this is the particular process which can be taken into the consideration for understanding the successive layers. Like there is a particular cross section, or you can say contour, that contour repeats itself, or that contours can be turned at the different level of height, and that particular different level of height joined together to form a component. So this is the second point which makes it little bit different with the different other technologies. Another, the third point is each of these layer can be seen as a thinly sliced horizontal cross section. Actually, this is a point where you can state that, like this is very much convinced for like what component is came out from what process. Like if you are looking at additively manufactured product, that can be identified with the help of those thin layers which can be appear just after the production of it. So this point identifies the process, how it is different from the existing process. Like you are creating through the injection molded part, you won't find the thin layers on the surface of it. But if you are creating it through the additive manufacturing process, then in additive manufacturing process, you will find the thin layers. Whether it may be the 50 micron, it may be the 10 micron, it may be the 100 micron, it may be the 200 micron. But there would be the thin sliced layers which would be visible, may not be visible with the naked eyes, but those all would be there and would be visible with some aids. So it would be there. Like in SLA process, you won't be able to see with the naked eyes in most of the cases, but you can have you can always have those layers in each and every additively manufactured process. So this is the difference, how you can identify your component, how it has been manufactured, whether it is from the conventional process or from the different additive manufacturing process. So there are different additive manufacturing process classifications are there according to the materials, according to the different specifications. We will come on to that in the further slides. So this is the basic process which follows through the additive manufacturing process. So first of all, we should have a CAD model with us. That CAD model can come from any kind of CAD software. It is not like specifically that should be from mechanical, that should be like a manufacturing software, that should be like most of the people think that only uh, AutoCAD, or you can say SolidWorks or Creo, these all are the CAD software. Every CAD software which is there, which is associated in order to bring a 3D design, all those softwares are known as CAD softwares. So whether it is a 3ds Max, whether it is Maya, whether it is some magics, mimics in your medical applications, and if you are having some reverse engineering softwares, there are Solid Edge software which is well known for reverse engineering purposes. So every different software which can give you the 3D model in any kind of format, you can say like STL format is very widely available on every software. There is no software which is not having the compatibility with the STL file format. It can export like any software can export in STL file format. So this is the most universal file format which is there, which is available in every software. So whether it is from medical, there are different Mestro 3D from dental applications, there are ExoCAD from dental applications. So there are various software which are available for various applications because there are specific features associated to the software. Like if we are talking about the mechanical engineering softwares, in mechanical engineering software we are having certain constraint in it. Like we should have a specific tolerances, we should have specific like material compatibility according to the design. So all those foundations are there. But in biological applications, biological models, you need not to get into those constraints. You can create a part, you can even scan the component and directly use that scanned model in order to create the geometry or the physical component. So every 3D CAD software can be used in order to build your component in 3D printing. So every software is having a capability to export the HTML file format. If it is not having, then it should have some alternative support file format, which may be .obj, which may be .dicom file format, which is specifically for CT scanning purposes. You would find it from like CT scanners. Actually, it also scans in layer by layer system, and on the basis of those layer by layer images, it can create the DICOM file format, which can further convert it into the STL file format. So there are the various alternatives as well if you are not getting directly output in the form of STL. So there are also the third party softwares. So the first thing is to achieve the file, achieve the CAD model, achieve the STL file. So that can be achieved with the, like you can say, CAD software that can be achieved with the help of some 3D scanning operations. But the thing is, like if you are having a typed document with you, you have typed it in Word or something, and you are taking a printout of it. On the other hand, you can have a scanned document with you, and you are taking a printout of it. So there will be bit difference in those two things. Like one is the typed one will be having the refined and the specific features onto the printout. But one which is the scanned, that would have some dull feature on it. There would be some like edges, there would be some like shadows on the paper. You will find you will feel it when it will be getting out from it. So there are some alternative softwares as well in order to refine those scanned data. So in 2D, we generally know Photoshop and all those Corel Draw and all those different softwares are there, Illustrator and different softwares are there. But in order to refine the scanned 3D scanned model, there are the different software which are typically known as the reverse engineering softwares, which can give you the refined output. So whether you are scanning something, like you have scanned something like an object, or you are scanning like a paper, like you are scanning a document, that document can be refined with the help of those softwares. What is that refinement? It can convert that file into the vector form. In the same way, whatever you are scanning, uh, one object you are scanning, that object could be in the form of raster images. That raster images can be converted into a vector file with the help of reverse engineering softwares. There are the various tools which can convert into that. So which is very much required in mechanical engineering or some relevant engineering technologies. So which is very much required in that. So it is very important to get the refined data. So that is why there is third party softwares, or you can say some softwares which are available in order to refine the raster image into the vector image or to convert into the vector format, so that we would have all those constraints in it. But in most of the applications, like you can have some biomedical applications there, it may not be required. So that depends on your applications as well. So this is the thing where you need to have some refined data or a data which is having the 3D representation of it. You can have the HTML file format with you. This is the one thing. The second thing, then you will be having the further operation which is known as your mesh review. Once the data get exported, suppose you have exported the data from a software which is known as SolidWorks, that SolidWorks exported the data. If there are multiple fine geometries are there, like there are some internal grooves, there may be some specific geometries which cannot be easily converted into the triangulation form. So that particular export may have some losses. So every export or every transfer of file will have some losses. Like if you are transferring some data from one place to another place with the means of WhatsApp, with the means of mails, with the means of any kind of transportation medium, then there would be some data loss. So in the same way, if you are exporting a specific file, like you are exporting a CAD file into the STL file format, there would be some data loss. There may be the missing of triangles, there may be some overlapping, there may be the edges missing, all those things would be there. Triangulation means you have to fill the whole structure or the whole surface with the facets of triangle. Those facets of triangle repeats itself according to the geometry. Like more the triangles, more the resolution would be there. So that we will be discussing in further slides. So there will be the mesh review system, that may be the third party software that may be incorporated within the software which is dedicated for slicing for the particular machine. So this will be totally dependent on your infrastructure, how you are doing that particular process. So there will be the mesh review system would be there. It will identify the issues which are there within the mesh. After that we have to export the mesh further, and then we have to fix it, like whatever the triangles are missing, whatever the edges are missing, whatever the features are missing, that can be fixed with the help of fixing. That is further dependent on your infrastructure, how you are doing it. You are doing it with the third party software, or you are doing it with the software which is dedicated for slicing. Then after the fixing, that can be further exported. And then there is a process which is known as preparing and printing. So preparing means you are making slicing model. So whatever the file you are having with you in the form of STL, that cannot be directly read by your machine. So machine will read a specific language. That language is known as .decode file. So preparing the data is something which is done by a specific software which is known as slicer. So in that particular software, we can set certain parameters like layer resolution, we can set there, like filling density, we can set there in various technologies. Like there are some set technologies where we cannot set the filling density, we can only set the layer resolution. In some technologies, we cannot even set the layer resolutions as well. We can set various parameters in various technologies. So all those settings can be done through this particular software which is known as slicer, and that slicer slices the component or the digital model in order to give the command to the machine. So that command is in the form of .decode file. Some of the companies having their specific G-code file formats. So that may be dependent on the companies as well, because there are some dedicated systems, there are some open source systems now available in the market. So that will be totally dependent on the infrastructure what you are having with you. So that particular G-code file, in general, we know it for G-code file. So that G-code file can be transferred onto the machine, and in that way, it can read that particular G-code file, and accordingly, your tools will move. So like in CNC, you are having G code and M code and different codes in order to do the different operations. In the same way, in this particular thing, in 3D printing technology, you will be having the tools with you. That may be the nozzle, that may be the head, that may be the laser, that may be anything. Whatever the things are there, accordingly your G code will be created, and those G code can be read by your machine, and accordingly your part will build layer by layer. This is the alternative way of representing the same thing. So the first of all, you will be having the CAD based model with you, then that can be converted into the STL file, and then you will be having the slice layer in the third view, and then AM system you will be having, and after the completion of your component, like you can, in most of the technology, you will be having the process of post processing, because in most of the technologies you cannot directly use the component. So post processing is also there. So you have to finish the component after taking it out from the machine. So these things are there. Only a few technologies are there which can give you the part directly in order to use. So there are few technologies. Along with that, there are some designs as well which require the post processing. And if you are having a design and the machine itself with you, then you can directly use the component just after taking it out from the machine. So this is a process which is there related to your additive manufacturing. So let me play a video in order to understand the process. So this is you can say a process which is a nozzle based process which will be playing here. So this is just a representation how the process works, but the process for different like technology will be different. But this is just a representation of the process which is a generalized process which explains the process in a way like how with the layer by layer deposition will happen and how the component will build it. So in this process, you can clearly see the build platform. This particular part is known as build platform. This is known as nozzle. So this is moving towards the Z axis in the negative direction. This you can consider as the negative direction because it is moving downward. If it will be going upward, you can consider it as the positive direction. Then you are having negative and the positive direction, but this is a first quadrant system. So all the motions which are there are positive because if you are considering this is a center, so any axis x or y will be having the positive coordinates. But if it is moving backward, then it can be considered as negative, and if it is moving to and forth, then also you can consider accordingly. So this building operation is done with the help of this particular nozzle. So this nozzle is there which is depositing the material. So there are the different technologies in order to do the deposition, but this is a simple representation in order to do the generalized thing. So this build platform moving downward, in most of the cases, you will find this kind of arrangement. But in some cases, you may have some Y and the Z motion on the build platform. In some cases, you will find that Z will be the static and the every operation will be performed by this particular spindle. So you will be having the various mechanisms in it. But the whole thing is that the deposition of layer will be happening with the help of motion of X, Y, and G. So this is a Cartesian system here itself. Some of the technologies are having a delta mechanism as well. In that delta mechanism, there are all three axes work together in order to build the component. So this is that is a different mechanism which is there. But 90% of the machines would be based on the Cartesian mechanism. So this is how a component get built through the layer by layer deposition. So there is another video which will show you some applications as well, and this will also give you the idea how this is changing the whole world.
So 3D printing is taking over the world, but
Sir, please confirm, is the voice is audible with the video?
Yes, sir.
Okay. Thank you.
How does it actually work? Well, it's quite similar to a normal printer, but then a little different. First, you don't put in an ink cartridge, but instead connect a spool of special printing material like plastic, rubber, or even metal. And you don't print boring text documents, but real-life models of what you've just made on your computer screen. Simply awesome. Right now, you can buy a 3D printer yourself and make complex 3D models with modeling software. But if you're not really a wizard with all that technical stuff, you can buy personalized 3D models online, like
So,
plastic, rubber, or even metal. And you don't print boring text documents, but real-life models of what you've just made on your computer screen. Simply awesome. Right now, you can buy a 3D printer yourself and make complex 3D models with modeling software. But if you're not really a wizard with all that technical stuff, you can buy personalized 3D models online, like fancy toys, bracelets, or phone cases. Then send it to a 3D print shop nearby, choose the material, and pick up your own unique item. Sweet. In the medical world, they're developing 3D printers with special biological material. They're working on printing heart valves, ears, bones, skin, and even printed a small human kidney that can live for 3 months. It's just amazing. And hold on to your seats. They're developing a 3D printer that can print in space and are planning to print a moon base. A moon base! But, still, the coolest thing you can print with a 3D printer is another 3D printer. Booyah!
So this was the like an idea what all different things can be done with the help of 3D printing. So it is not only associated with the mechanical engineering, it is associated with almost every field you whatever you know so far. So there is a difference between the subtractive and the additive manufacturing system. So if you look at this particular picture, it identifies the differences. So there is a subtractive process here it is. So in this particular thing, in order to get this spherical part, you need to have a block with you. You need to do some machining operation onto that block in order to convert it into the spherical shape. In the other hand, if you are having the material with you in any form, like you are having the material in specifically in the form of wire, in the form of powder, in any kind of form, you will be having the material, raw material with you. That raw material can deposit layer by layer, and in order to get deposition layer by layer, it may turn into the spherical surface. So this is the simply the slicing of that particular sphere can make a sphere out of the raw material. So it can be understood through this particular video. So this is additive manufacturing process where you are building the component in a particular direction by depositing layers. On the other hand, you are having a subtractive manufacturing process with you. You are having a block with you and you are doing the machining operation, and the rest of the part which is there is a complete waste. You have to reduce that part. But here in additive manufacturing process, if you look at this particular thing, it is depositing material from this direction and no wastage is there, but that wastage was there. So you are having several advantages of additive manufacturing process. If you are comparing it with the different technologies, then you will be having a best advantage here, which is a complex shapes. There are the various complex shapes which are not even you can think to develop with the different technologies. Those shapes can be created with the help of additive manufacturing process. You are having freedom for design. there is certain example, like you can say, like right now I am sitting in my cabin and I am thinking of some design. So whatever I am thinking right now, that can be transformed into the product immediately just after my thinking, if I am having a, 3D printer with me. So now there is no challenge in order to convert your ideas into reality. So you can convert your ideas into reality. So it will give you more freedom in order to think about the problems you are having right now without those devices. Like some devices are there, you are thinking in your mind, like that can solve my particular problem. That problem can be resolved immediately. Just you have to design it onto the CAD software and then export it into a STL file format and then fire onto the 3D printer. Then you will get your real design in your hands. Then you are having customized parts. So this is the huge market nowadays. It is growing in billions. So why it is so? Because in customization, if you look at the prosthetics business, so in prosthetics, earlier days there was only some options was there. There was no customization because there was lack of technology. Now, if somebody lose his feet, lose his limbs or something, then that can be analyzed with the help of software, that can be scanned with the help of scanner, and on the basis of analysis of the structure, on the basis of body mass, it can be customized. You must be aware, like nowadays the players of like you can say Indian cricket team, you can say, there most of the shoes and different pads and all those things are very much customized. So all those customization done through these technologies only, because on the basis of their comfort, on the basis of their like strength, and different analysis gone through within the software. On the basis of that analysis, you can get those customized equipments or the parts for or you can say shoes for that particular player. Then last which you have already seen the differences between the subtractive technology and the additive technology. Whatever the block you are having, that waste part would be minimum in this particular technology, because if you are converting, actually this is a kind of forming process. So if you are converting a material from one form to another form, so it will reduce a huge waste, so which is very less in this particular technology, which you will find in subtractive technology, you will find in a huge amount. So there are some more advantages in it, which is fewer unsold products. Like nowadays, if you look at the different companies, so there is one company which is known as General Motors, another company which is known as Ambassador. So these two companies are closed in India. So if somebody is having a car which is made of this particular company, you can say Ambassador, you can say it's a Chevrolet. So Chevrolet company is no more providing support, or the Ambassador company is no more providing support for their spares. So all those spares can be created with the help of your additive manufacturing technology, or you can say reverse engineering technology. So what you can do, where if you are having a old component, old spare, which is having some issues in it, you can scan that particular component and refine according to the issues in the RE software, and then convert it into the STL file format and export it onto the machine, and you can get the whole new component in order to replace that component. So all those spares can also be created. So this is very much like great thing for those who are having already having those obsolete components with them. So in order to repair them, in order to their maintenance, they can create all those spares for them. Then there is another thing which is less transport. This is something which is very important, because nowadays there are some shipping industries are there. There are some, like you can say, aerospace industries are there. So in shipping or aerospace industry, there is a challenge with them. What's that challenge is, while they are traveling through the oceans, or in aerospace industry they are traveling through the space, they carry their spares with them, which are like having some lives in order to do the replacement, those components which may have some malfunction. So in order to replace them, they need to carry some inventory with them. But with the help of 3D printing, what they can do, they can only carry a 3D printer along with the CAD files of that particular component which they want to replace, and some raw material with them. Whatever the component, they will be having some issue in that or the malfunction in that, that can be replaced on demand. Like they can create their component themselves at the board. So once they will identify the component, that component is having some issue, then that component can be print through the 3D printer, and that can be replaced very easily. So this is something which is also an innovation in this particular thing. So these are some complex shape. I am guaranteeing, apart from this particular 3D printing operations, you won't find any technology that can create those components on like apart from 3D printing, it is not possible. So these are some ideas which can be converted into the physical model. So these are some examples of that. So these are some customized parts for prosthetics and some hearing aids as well. So these components can be like these different shapes. If you look at those shapes, those geometries, which are very well analyzed, and the material is also being classified. So if you look at this particular component, you will find there is a little amount of material in the form of powder that can be converted, and this much of amount is waste. But if you are machining a component from a block, then this much of waste would be there. So there are some, like you can say, study in it. This, what are the different solutions and the processes? How do you identify the process? How do you identify where to apply the additive manufacturing? So our think process is to doing it. There is a triangle with us, which is having a process parameter, which is having a system, which is having a material. Suppose a person came to me and told me that he need to print a bio organ. So first of all, his priority is to print a bio organ, and that should be biocompatible. So first priority would be the material. And in order to get that material, whatever the design is there, on the basis of that we have to set some process parameter, and accordingly we have to choose the system. So this triangle is interdependent to each other. So how this will work? Like somebody says, I need more strength in the component. So first thing which came into the mind of a person is that for the strength is like what material should be used for that particular strength. We have to go with the different parameters of strength, like what kind of strength, in what way we will be requiring the strength. So on the basis of that, we have to identify the material which is good for tensile, which is good for compressive, which is good for some other strength, like where the modulus is required, what are the different things are required. So on the basis of material, we have to identify like what process parameters and the system need to address. Like if somebody came to me and say, I want a part which should be in PA12 material, or you can say nylon 6 material. So I would have certain solutions with me which will be having the capability to do that. So if we are talking about the nylon, then there are the different technologies. But I have to identify their strength, I have to identify their process parameters in that. Like there are two technologies, I am taking an example. So there are two technologies. One is FFF technology, fused filament fabrication, which is also known as FDP. There is alternative technology which is known as SLS. Both the technologies can work on nylon, but the difference is, like in SLS technology, there is homogeneous strength throughout the component. But if you are going with FFF technology, then there is a compromised strength in the Z direction. So if your design, you have to find out some process parameters as well, like where it will be fit, where the forces will be applicable. If the tangential force will be applicable in the Z direction, it will be definitely get fractured. So in order to identify the application, we have to set up everything as per the requirement of application. So on the basis of requirement of application, we have to identify the material, we have to identify the system, we have to identify the process parameters. So like somebody asked me that like I want to have the higher resolution component, but I can compromise with the strength. Then the answer would be the system should be go with stereolithography or the polygatting technology. So these are the two technologies which are having the capability to give the higher resolution. So this triangles give the overall idea how to identify the technology. In the same way, if somebody is doing research, if he is writing a paper, then he has to identify the different parameters on the basis of their research. Like if somebody is finding strength of a particular material with a different technology. So it is basically dependent on his requirement. Like what are the different parameters he is looking for. So if the maximum tensile strength he is looking for, then the orientation, the material requirements, and the system requirement, all those things will be there. So orientation will come into the process parameters. So these are the three main points in the triangle which identifies the quality material properties. And after finding it out, the quality material properties, we can go on to the production. That production can be done through the identified machine. So after getting into the production, we can save the prices, we can save the quantity and the hours and the time onto the same. Because we have in this particular industry, we do not have space to lose the time. Because if we are getting a component out with the three different technologies, the cost will be higher. Let's say a person is asking me, these are the things I will be requiring. And that person should be addressed with with the help of this particular triangle. We cannot say like we will try in this material, we will try on this technology, then we will try on this. If we are creating 6 parts in order to give him one solution, then it will lose his time, it will lose his money. So this approach won't help in order to get the right output. So this is a process approach in order to do the solution. So this is the process chain which he follows after identifying everything. So first of all, like a person is having his design ready, then the design part can be skipped. But if the design is not ready, then we have to specify the design rule. If he is okay in order to changing the design, like there are some generative shapes, there are the additive manufacturing designs are there, part integrations are there. Like I would take an example. There was a horse which was fitted into a Formula One race car. So that horse was having a different geometry. Different components which were assembled together. But there was no necessity of doing that. That can be replaced with a single component. So what we did, we take out all those different components and does the scanning, and after the scanning we create a single generative design. That single generative design was generated on the 3D printer, and that was placed into the car, and it was very much successful. It was lightweight than the previous one. It was convinced it was very much, you can say it was very beautiful kind of component. It was fits well into the system, and it was also reduce the chances of leakage due to the less number of joints in that. So leakage chances was also reduced there. So it was obviously increased the efficiency of that particular car. So this was one case was there, which I had discussed with you. So the design is very important thing. Some people are open for the generative designs. They want to change their design in order to get the generative shapes, because in generative shapes they can reduce the shapes, they can reduce the cost, they can reduce the weight of the component. I will explain one case study with you, which is already here in the slides. In the further slides you will find it. Then you can identify the, on the basis of this triangle, you can identify the printing operation, and then you can go with the post processing operation. Those post processing operation will further dependent on your application and used applications and your different material compatibility. So these are the three different things we have to follow in brackets. So the first thing is to identify the design in software. Then the second thing, in order to identify the material, process parameter, and the machine. Then the post-processing operation on the basis of end-use application. Like somebody is having the application of biomedical application, then for biomedical application, we will requiring a material which is a biocompatible and self-sterilized. And after the getting the printing done, then you have to do the sterilization again with the material. So that sterilization would be the post-processing operation. So these are the different things we have to consider with according to the applications and according to the requirement of the persons. So this is a thing which is associated to the design. If you look at a particular sphere which is having the same dimensions with the different parameters. So while you are having upper three, you can say the upper three shapes. If you are looking at those upper three shapes, you will be having 240 triangles and the tolerance is 0.1. So if you look at this particular shape of this sphere, that is having some steps in it. So there are some sharp edges onto it. So this will give you some problem. So in order to do the designing, you have to identify the resolution of your digital model. So that resolution should not be like this. This may have the smaller size of your file that can be easily transported, but that will be having issues in order to get the output. So if you look at the output, then output would be like this. Then you will be having the tolerances limit of this 0.01, which will give you the 2400 triangles. The size of the file would be little bit bigger than this, but the resolution would be fine. So you will not feel like it is not the continuous spherical geometry. You will feel it very much smooth. But if you want more smooth, then you have to identify the more triangles. So on the basis of this design analysis, you can identify according to the applications. Like if somebody is having application of jewelry, then he would definitely go with this because the parts will be small. So small parts can be converted into the dense triangulation, and those dense triangulations can extract the dense features of it. So if somebody is having the application of jewelry, then he can go with this. If somebody is having the applications of, like you can say, mechanical engineering, then he can go for it. But in some cases, in most of the those cases where the design is not so important and features are not so important, just they need to extract the outer structure, like the larger size of casted material. In those cases, you can go with such low resolution files. So this is very important thing you have to address according to your applications. Most of the cases you will be using this, and this will be used for those applications where the high resolution matters. So this is that case I was discussing with you for the generative shapes. So this is you can look at this. This is a cycle pedal, which is a conventionally manufactured, and we transfer it to the additively manufactured system slicing software. In that slicing software, we found this is a raft structure which was there. These are the support structures which are there in represented in yellow color. So these yellow color support structures are there which are holding these overhang. So let me explain the support structure. Those who are not aware, if you are building a component in a system which is based on additive manufacturing or layer by layer deposition system, it will be depositing from bottom to top. So while it will be depositing at this particular region, so there is no material between these two surfaces. So in those cases, what will happen while it will be depositing the material on this particular portion, it may drop down here. In some technologies, this problem would not be there, like in SLS plastic polymer technology. You won't find this particular problem because the powder will be filled over here. So the powder will play the role of support structure. Like you are building a house for you, and uh, you are putting a roof for the house, then that roof will have some require some support structure initially before settle down. So before settling down, it will be requiring some support structure in the form of sheets and in the form of some like rod structures. Those rod structures will hold the sheet structure, and on the sheet structure you will put the slurry of your concrete. So that concrete, once the concrete will set, then you can remove those support structures. So in the same way, while you are building a component, during the building operations, you have to create the support structure for that. So this was in the slicing software, these much of support structures was there. Then we have modified something into the design, like by using the approach of conventional design modification. So this was only the conventional design modification approach. In this conventional design modification approach, we were able to reduce this much of support in this particular design, and we were able to reduce this much of support in this particular design. But in this particular design, you may find there is a huge increment in the material usage. So in this particular design, you may see this may have some weight higher side. So the weight of this particular component is more than this particular component. So this was, or this may not be the good idea for a cycle, because nowadays people are going to reduce the weight of cycles. So this may not be the good idea. And here we were not able to reduce the support so much. Then there is another way of doing it. We can play with the orientations as well. So we tried without going with the horizontal way of doing it. We can print it into the vertical way. So there was these support structures was there. So it was reduced with the support structure, but still it was there. Then further we have changed something, so we can give some ovality onto the edges, then you can reduce the complete support structure. So we have reduced the support structure with this particular design. But still it is not the generative design. So what generative design is? So this is a way of creating a design in a generative way. In this particular way, you are able to reduce the support structure. It is quite beautiful if you are comparing it with it. And it is very simple, and it is not having a support structure in this particular moment. And you can even create more generative designs in this particular technology. These are the more generative designs which were not very easy to create in the conventional process, as well as for those all different generative shape designs. Usually these components are made out of your injection molding process. So molds cannot be created out for these particular pedals, you can say. So these are only possible in additive manufacturing process. So generative design applications are there. This is another case which belongs to your aircraft. So a typical commercial aircraft will be having a 850 seat belts, and a particular seat belt will be having a weight of 155 gram in steel, 120 gram in aluminum. So this is a, you can say this is a hardcore steel is there, or the aluminum is there, which is having a lot of weight in it. So if you are going to do reduction in weight as well as the generative design, you can have like this. So it has reduced the 68 gram without compromising the strength. And the same thing if you are doing with the subtractive manufacturing or the some alternative process, then you will be having more money to invest. But with the additive manufacturing process, you can change these different, you can reduce the weight, you can save the material, you can also save the, like these designs are very well, these are the generative shapes, and this is not compromising the strength, apart from that this is lightweight and it is safe onto the material and the cost. So this is the thing which we can do through the additive manufacturing process. So limitations are also there, not only the advantages and the different things. So limitations are also there. So the first limitation is there. Up to a certain, like it is not exactly you can say the limitation. You can also consider it as some other way you can consider it. Like time is not limitation for a particular batch of production. Like if you are having a limited quantity to produce, then the time would be less. But if you are creating a bulk quantity from for the component, like you need 1 lakh or 2 lakh pieces of a component, then in those cases the time would be the limitation for this. But if you are going with the 1000 or 2000, then the time would not be more. So it will take less time for that. So this is one thing which is there as a limitation. Then the cost, as typically in India, in also globally, you can say nowadays this technology is not very much common. So it is not available like you can see CNC technology is available almost everywhere, but it is very hard to find. Like if you are considering the small cities, then small cities are not accessible with this technology. But in like coming years, we may expect that these may be available in small cities as well, along with the metro cities. So cost is there, which is a great parameter for this. Once the cost goes down, then it may be very much easily accessible to most of the people. So cost is the parameter, not only the initial investment, also the running cost is also there, maintenance cost is also there. Then there is a third limitation, which is the skill. Right now, the people who are aware of the technology are very limited. Apart from that, the serviceability, repairability of a system is very difficult, and that repairability further requires more cost. So these two things are interrelated. Then the fourth point is material. So nowadays, if you look at the current scenario, almost we are having every material, but the further thing is the availability of material is not very easy. So availability is a difficulty with the material, and the material cost is further a challenge, and the lead time of accessibility of material is further a challenge. So these are the different challenges which are there, which soon we are expecting can be eliminated. So this is a slicing operation which we are talking about. So like this is a 3D CAD model, and these are the different slices over here, and this can be sliced portion can be deposited in this way. So this is the slicing operation. If you look at this particular thing, so the every contour of it is being sliced in the form of layers. So more the number of layers you would be having, more the resolution would be there. Less the number of layers would be there, less the resolution would be there. So that is why there are the different technologies which are based on liquid-based additive manufacturing system like stereolithography, polyjetting. All those technologies are having a very like they are having liquid materials like almost viscous material which can be deposited in fine layers. But the powder material or the plastic material, which is paste material, that cannot be deposited in a fine layers. So that is why the layer resolution would not be higher in case of other technologies than the stereolithography or the polyjet technology. So there are some roles which slicer plays. So slicer may repair the STL file or modify the STL file. So these are the operations which are optional, which may be available in the particular software, which may not be available in the particular software. So that will be totally depend on the software, what software you are using. So repair or modify of STL file could be there. These are the optional features. Then printing position you can set, like earlier we have discussed that orientation part and the positioning at what point you want to do the printing. That positioning you can setting on the basis of output desire, like you want to print a component in hollow, you want to print a partially filled component, you want to print a solid filled component, then you can do on the basis of this. Apart from that, you can select the layer resolutions, like I had told you earlier, like layer resolution can also be set within the slicing software, but that will be further dependent on your requirement or on your machine or the system chose. So whatever the system you have chosen, on the basis of that system, you would be able to do the different settings. So creating layers and exporting into the G-code files. So layers creation, that is always be there, and export into the G-code. G-code is the like general file format that may be named as the different with the different companies, but the generalized format of file would be the G-code. So this feature will always be there in each and every slicer. Apart from that, some slicers may give you the material uses and the time estimation. You have loaded a component, that component will require the 25 gram or the 30 gram of material and estimation time, like it will take half an hour or 1 hour to complete. So that estimation can be done within the slicing software. So these are the different operations that you can go through the slicing software. So these are the different applications. So there are most of the applications has been covered, and there are many more applications apart from these applications. So these are some components related to the relevant technology. You can look at this automotive applications. All those automotive components can be developed. Most of them may be the prototypes, but the customized automotive vehicles can be created. Customized planes can be created directly with the specific material. But the majority of it is now in the prototyping section. These are some prototypes of aerospace applications. These are the medical applications. You can do the printing. You can directly print the implants as well, like bone implant, titanium, SS can be created with the 3D printing technology. These are the dental applications. Nowadays, this is the trend which is there to create the clear aligners, which is also known as bases that you can create. And the surgical guides you can also have. These are the different things you can create. All those things can be biocompatible. Even you can directly create the dentures out of the 3D printing, because there are the biocompatible materials which are available, and you can create the dentures with the different sets of it. Like you can see, this particular set is in the pink. Like that pink may have the different sets. Like your teeth are there, then those teeth will have the different sets of white. So that may be the clear white, that may be the different polar white or different white are there. So all those whites and those like gum texture can also be created with the help of 3D printing. So these things are there. You can create directly for the medical or the dental applications. So these are the actual prosthetics which can be created. So these are some engineering prototypes which can be created. These are the real construction prototypes, you can say, on the construction. Like you can directly print homes as well. There is a company known as Delta West, which works on the Delta mechanism, and this particular machine is from D-shape. So D-shape machine uses the binder along with the sand. So sand and binder join together to form the houses. Most of the houses, like for rescue camps, those all can be 3D printed in European countries. This is a trend in China. This is a trend nowadays. So their rescue camps, and now recently you have seen China has built up some of the COVID centers in the record time. So those all were built up through the 3D printing technologies. So these are the most known technologies you can find. People are having it. So these are the most common technologies which are available, like fused deposition modeling, which is also known as FDM, multi-jet modeling, MJM or MJF, also this is known as color jet printing, and stereolithography, SLA, selective laser sintering, SLS, EBAM, and DED, electron beam additive manufacturing, and direct energy deposition. These are the technologies. Basically, these are the commercial names of the technology. Some of them are based on the technology, some of them are based on the marketing name. So like this is the color jet printing is a marketing name of it, and this multi-jet modeling is also the marketing. Beside it, these are the technologies name. So these are the technologies name which are there with the companies. So this can be further classified in this way. So there are three basic classifications for the technologies and the machine. So the first classification is based on the liquid-based additive manufacturing system. So it means that the additive manufacturing system will be having a liquid-based material as a working component. So you will be using the liquid material in order to building the component. So there are the two technologies which I have included. Actually, there are many more technologies are there, and many different companies are having with the different names. So what I have included SLA, which is a common thing like stereolithography, and there are some modifications in the same technology, which is also known as DLP. Some are patented technologies like LFS, low force stereolithography. So there are the different technologies like LED based DLP, projector based DLP, then screen based DLP. So all those technologies are associated with this stereolithography technology. That is why I have considered only the one technology which is known as stereolithography, which is SLA. So the full form is stereolithography apparatus, and then material jetting. This is further having the different names, the different way of doing it, and the different materials and the different like there are some chemical process may be there. There may be some like cooling and heating process may be there. So these are the different, like the main principle of the technology would be the material jetting, but there are the different companies having the different names and the different procedure of doing it. So this is based on the liquid-based additive manufacturing system, where the material which you will be using the technology in the form of liquid. Then there is powder-based additive manufacturing system. The most common is selective laser sintering, which is basically for metal as well as for plastic. So both the materials can be used with this particular technology. So this is a single technology currently available, which can print in both plastic and metal directly. So this is a direct printing technology for plastic and metal, but the system would be different. Like the same machine cannot be used for plastic, same machine cannot be used for metal if there is plastic in the metal machine. Then there is binder jetting technology. This is further having the different names with it, but this is the generalized name again. And apart from that, in powder-based additive manufacturing system, little bit of differences are there. So there are some inkjet technologies are there, multi-jetting fusion technologies are there. So there are the different technologies which are available there. I will also explain one more technology which is coming from HP. So HP is having its different models. There is a color-based additive manufacturing system as well. So HP technology is known as multi-jet fusion technology or jetting fusion technology, you can say. So this is also there, which is quite similar to SLS technology. There is only the process difference, or you can say the principal difference in that. So they uses the agent instead of using the laser, but in SLS they typically uses the laser. CO2 laser is there. Then there is the third technology which is known as solid-based additive manufacturing system, where the solid form of material is used, and then that can be melt or that can be the 10 joined together. So there are two basic technologies are there. One is laminated object manufacturing, another is fused filament fabrication, which is also known as fluid deposition modeling. So one by one, I am explaining to you, and I will show you the differences in it. So this is a very first technology, which is stereolithography technology, which is also considered as the similar technology to digital light processing, which is DLP technology. Then low force stereolithography is also the similar kind of technology. Only the difference is there little bit of construction of this particular machine, a little bit of the process of this machine, but the rest of the principle remains same. Because in this particular technology, the basic principle is the photopolymerization process. So there is a liquid-based material, which is typically a resin, which is in the form of monomer, which can get converted into the polymer with the application of a specific light. That light may be the UV light, that may be some specific intensified light. Usually 99% of resins can be cured with the help of UV light. So that is why most of those are the UV laser lights are there, or the LED lights are there, or most of the projectors which you are having for the presentations, or you can have some mobile screen or the tablets, or you can say some laptop screens. All those light components are having some UV components in it. So with the help of those UV components, you can do the curing operation layer by layer with the liquid monomer material in order to convert that into the polymers with the help of photopolymerization process. That process requires the different arrangements. Those arrangements can be changed, but the basic principles remain same. So in this particular figure, this is a typical stereolithography system, which is also known as wet polymerization. So polymerization is nothing but just a photopolymerization process to convert the monomer material into the polymer. And wet is this particular tank is known as wet. So this wet is very much different in DLP, is very much different in most of the different SLA technology, which are having the different mechanism in it. But in this particular mechanism, if you are understanding this process, then those processes are quite similar. Those are having some little bit of difference in it, but the process remains same. So there is a laser unit which emits the laser light, and there are some lenses which can convert the light and concentrate the light towards the lens. That lens navigates the laser light towards the focusing area, wherever you want to focus, wherever you want to cure the material. So this will be navigated with the help of a motor. That motor regulates its XY motions. So this is known as galvano as well. So those galvanos impacted the concentrated light or the laser beam onto the platform where you want to do the curing operation, and this process repeats itself layer by layer. So what will happen? The laser light will come and concentrate with the help of lenses, and with the help of XY mirror, it will be reflected at the different portion of the build platform. And this is a build platform which is having some sieve holes in it. So those sieve holes will allow to resin to drain out, and this will move up and down. Then there is a sweeper here, which is also known as a wiper, you can say. Those wipes up the excess materials in order to control the layer resolution. Like you have identified this particular layer, if you consider it as 100 micron, then it will control it at the 100 micron layer resolution. After deposition of each resin, resin spill over it, and then this leveler, or you can say sweeper, ensures the resolution would be in a controlled way. So it will distribute the resin homogeneously, and with the help of this laser, it will cure throughoutly in order to form the solidification. So this repeats itself up and down, and in this way your part gets built. So this particular process involves the photopolymerization process, and these all different equipments help in order to get it into the controlled way. I am showing you the this particular video in order to make you understand more.
Prototyping. Creating a sample part or object before production and manufacturing ensures desired form and function of the final part or design. Modern prototyping can reflect the final design, thereby improving design time by up to 50%. Companies can easily and quickly find out how the part interacts with the environment which it was designed for. They can hold it, test it, and feel it to ensure the geometry and design is what they wanted. One of the main processes for high-end prototyping is called SLA, stereolithography apparatus. An SLA system creates plastic parts by curing ultraviolet sensitive resin with a UV laser. The SLA system consists of a UV laser, a build platform, a vat of photocurable liquid resin, and a computer system that controls the entire machine. All that you need to get started is a 3D model of your desired prototype, either from a CAD software package or a 3D animation software package. This is all that is necessary to provide build information to the SLA system. Special software then cuts the 3D or CAD file into thousands of layers per inch, called slices, and outputs the slice data to the SLA system. First, a platform is lowered into the vat of resin and is leveled off at the very top of the vat. The UV laser then draws the first layer shape into the resin, solidifying the first slice onto the platform. After the first slice is cured by the laser, the platform then lowers into the resin anywhere from 1 to 7/1000ths of an inch, depending on the desired resolution. The recoater arm then sweeps across the top of the previous slice, layering a film of resin that is then cured by the UV laser again. This process repeats as the platform lowers into the vat, and the part is built layer by layer. Within a few hours, the part is complete, containing most or all of the detail from the original 3D file.
There is another video related to this. This is a DLP technology actually. So the difference is the part is building in the invert way. So the base of the part is just attached onto this build platform in the reverse direction. So this is the only difference, and this light which you are looking at it is from a projector. These are the two different ways of doing the stereolithography. So the first advantage with this particular technology is that we can get the higher resolution up to 10 microns. So the resolution could be very nice, and the accuracy will also be varies from 10 to 25 microns. So accuracy will be very high on this particular technology because there is no shrinkage in the material, there is no expansion in the material. This is just a chemical process, so the accuracy and the resolution will be great. And another advantage with this particular technology is that you can get some translucent object with this particular technology. If somebody requires a translucent geometry, translucent object, which can directly came out from the technology. So there is no other technology, you can say, which is having a transparent feature in it. Apart from this SLA, only PolyJet technology is there, which is having those features. That is also have one more advantage that can be done through the different colors as well. But in this particular technology, you can do the transparent. And the limitation with this particular technology is that the parts which came out from this are very fragile in nature. Those are not very strong. The standard properties as per ASTM or as per ISO, all those standard properties are missing in these materials because material may behave on the basis of their curing. So more the curing, more the strength of the part into there. So apart from that, the curing will also affect the geometry as well as the features of the component. So that is further more challenges in it. So the basic challenge with this particular technology is that the components may not be used for widely used for engineering applications. So this is basically for such applications which requires only the prototyping operations, some medical operations, some of the jewelry operations, you can say, because there are some materials which can have the zero S residual in castable wax form. So you can create the model in the castable wax resin. That model can give you the impression into the POP or the required mold. That can be the soft mold of silicon. So while pouring a hot material into that, then it will leave zero residual or 0.1% residual in that particular cavity. So that can be done through the investment casting process. So this is the great technology in order to address those applications. So then there is another liquid waste additive manufacturing system which is known as material jetting technology. So this can be done through various processes, and this is having the various name in industry. So this is a basic principle which I am showing you. So there is a print head which is there. That print head is at the liquid material in the form of fine droplets that can be deposited over the build platform. And with the help of heated build platform and the forced cooling, or you can say by the blower operations. So that forced cooling enables it to cool, and that cooling will set the deposited layers, liquid layers, into the solid form. So this is the one way of doing it. So that can be any kind of ceramic. You can say that ceramic can be deposited. Another way of doing it, there are certain technologies which are known as polyjet, multijet. All those technologies are there. So in those technologies, you will be having a resin material. So those resin materials can be deposited through the multiple nozzles. So that is why that is known as poly nozzles, or the multi nozzles are there. So those multi and poly nozzles deposits the material here, and with the help of UV light again, which can be inbuilt here only, or that can be inbuilt within the chamber only. So with the help of those UV light, it can be cured layer by layer, and in that way it can build a component. So there are the different ways of curing. Here it is curing with the help of blower and the heated bed, and there may be curing with the help of a fusing lamp which can be placed over the head or over the cabin. So this is a basic principle of doing it, and we are having some process over here which will explain about the multiple jetting process. So the design was created through there, and here with the machine you will find the different multiple nozzles allowing the material to the selective area to deposit. And there is one more thing, wherever the support is required, that support material may be deposited with the different material. Or in this particular technology, you can also do the different coloring, and you can also do the transparent operations, because the ejected material is resin itself. So resin would be there, which will be ejecting through the nozzle. So the process would be So in this particular technology, there are certain advantages and the disadvantages are there. It is quite similar to the SLA technology because there is a resin material which can be used in one way of it. Another way can have the POP or the ceramic material. But like you have seen this particular technology which is in this video. That technology is a polyjet technology and the machine was object. So in this particular machine, uh, there are certain advantages of it. So you can do rinse away support structure. So as you seen, there was some solvent was there that was applied onto that particular area and the support was rinse away. Apart from that, the layer height can be quite similar to your SLA process. So the resolution would be great in this particular technology. Apart from that, accuracy would also be great in this particular technology. And one advantage is there, which is over SLA, is you can use the multiple material over here. You can do multiple colors in this particular technology, which is an advantage over the SLA technology. But again, the disadvantage with this particular technology is that the parts fragile, remains in fragile nature. So which was also there in SLA technology. So this is a technology where you will find the same kind of disadvantages which was there in SLA technology. Then there is another technology which is known as selective laser sintering. So if you look at this particular picture, you will find the same way of doing it as you seen in SLA technology. So in SLA, what was there? There was the difference only of the liquid material. Here you are having the powder form material is there. And the laser, which was in SLA technology, which was of UV kind, but here you will be having CO2 laser in this particular technology, and which will be high intensified. The advantage with this technology is that this can use both the materials like plastic and metal. So it is compatible with both, but the systems are different for the different materials. Like if you are using the plastic material, then the system would be different. If you are using the metal, then the metal would be having a different system. But the principles remain same. So in this particular technology, what is there? There is a laser and the mirror, which was similar, which is similar as you have seen in the SLA technology, which will work in the same way for the X and the Y direction. And for the Z direction, there is a build platform over here. So this is a filled material which is there on the left bay, and the right bay is for the building the component. So with the help of roller, it is depositing the material in a certain layer height that can be varies from 100 micron to 120 microns in this particular process. So that can be deposited, and that material may be plastic, like PA12 and the PA11 are the most common plastics which can be used in this particular technology. With the help of this roller, you can deposit the material in a certain predefined layer height, and that layer height get cured, and accordingly this will go down, and this will go up in order to consume the material. The material will consume over here. The advantage with this particular technology is that you will not require any kind of support structure, and the powder reusability is very high. That will be further depend on your company, what company you are opting for. So reusability of powder would be there, and the support structure itself will play by the powder. So like this is a particular overhang. That overhang can be controlled with the help of the powder material which is already deposited over here during the layers. So the cured area is very much visible with this orange, and with the help of laser it has been cured layer by layer. So there is another advantage with the technology, which is like in this particular technology you will get the high strength component, but there is one more limitation is also there. It may have some rough surface in it, and it may have some porosity in the component, but whatever the strength is there, that would be homogeneous in nature, which is also there in SLA. But here the homogeneous strength is there, but that strength would be obviously greater than your SLA part component, because there is no component which can meet the characteristics of these materials. So that is why the strength would be more than the SLA technology. Layer resolution would be dependent like on the machine or the made